how much do you know about your own Docker images? Are they really secure? So how often, for example, do you run the image scanning? Are you using the multi-stage building for the images? So in this tutorial, I will guide you through all of these technical concepts. So this video is also part of the longer series on Docker securities, and in this specific video I decided to focus on Docker images, which is also something that you guys voted on community tab on YouTube. When we talk about the Docker images, very often cloud admin or DevOps engineers overlook this crucial part of the software development and download the pre-made Docker images from the public repositories, such as, for example, Docker Hub, which is, I think, absolutely fine, but we also need to be critical on what do we download from the internet, even from the public registries, such as the Docker Hub. There are many things that can and will go wrong if we just blindly trust the images from the internet. Just a quick recap. As we already might know, Docker image is like a frozen snapshot of the operating system, built in layers, and each layer represents a file system change, like for example installing packages, adding files, and all of these layers except the final ones are mounted as a read only. Now we also have the Docker containers on the other hand. So here we are running the instance of that image. So when we start the container with the docker run command, Docker adds a thin read-write layer on top of the image layers. So what makes this model vulnerable? Well, Docker, despite being isolated system, it is not as isolated as, for example, virtual machines. For start, containers share the same Linux kernel as the host. So this can result in getting to the VM to or from container much easier than from one VM to another. So of course, it's not always the case. It also very much depends on, for example, what was the last time your kernel module was updated? What is your Linux or AppArmor settings and general Linux hardenings that you perform? In this video tutorial, we'll discuss 3 ways that you can enhance the security of your Docker images. Let's go. Docker is also included in the LPI DevOps Engineer Tools certification. Click the link in the description to get 5% discount on the exam. Now let's come back to our training. Disable default user. One of the first things I would like to discuss is the default users of our containers, which is unfortunately root. So why it's even a security risk? Well, because even though the containers are isolated with the mechanisms such as, for example, namespaces or C groups, someone that has a root on the container and managed to escape your container because of the, for example, misconfigured Docker setup, volume mounts, or kernel vulnerabilities. We also discussed the Docker escape in the previous video. The person might also then have root access on your host machine. So to demonstrate the scenario with the user, I decided to write a quick Flask application that is printing the current user that is starting the container. We'll consider 2 scenarios in this application. First of all, we're going to build the application using insecure Docker image. Here we're just going to run our container as root. Then we're also going to run the second version of the image from the previous example, which is the secure Docker image. And here we are going to add a special command user that will create a dedicated Flask user to manage our application without sudo access. Let's try to build it. This is my Dockerfile, and you can see that it's pretty standard. So we have a from command, we have a run pip install Flask, we are copying the files with the command, with the copy command, we have a workdir, we expose port 5000, which is pretty standard for the Flask application, and then we execute the application code. I will now build the image with a docker build -t application app insecure -f, which is where we're going to provide our Docker file, and I want to build it here. So once the Dockerfile already built the application, after I run the container from it, we can go to the application, type whoami, and we can see that the application is running as root. So it's the same result if we, for example, decide to run the container with the docker exec command. We can see that the user that is running the container is root. Let's now consider the second scenario, Docker secure image. So as you can see, it's pretty much the same Dockerfile from the previous example, but we have some special commands that we also want to include. For start, apart from running install Flask, we're also going to run && user @-m Flask user. So in this line, we are creating the new user that will manage the application. Moving on, we also have a change copy command, because now we are not copying to the work dir, but we are copying the application code to home of our user. So this is the home Flask user-app. And in the end, we're also going to run the change mode to change the ownership of the file. So here I'm just going to run change own -r Flask user on our home directory. Once the image was built, we can run the container with docker run, and now I'm providing the name, the port, and I can see the application is running. From what you can see here, we have a dedicated user now that runs without any additional root privileges. So this solution really offers us an extra layer of security by preventing the application running as a root user inside the container. So this solution significantly reduces the potential damage in case of the container escape. Image vulnerability scanning. Let's discuss the vulnerability scanning process. Basically, it's a process of inspecting known software vulnerabilities, CVEs, in our operating system packages and libraries bundled within our image. So we have few tools available on the market. So we have Trivy, we have Claire, we have Gripe. So for the purpose of this exercise, let's look at Trivy. The most basic operation what we can do is just to run Trivy image and now the name of our image. So in my case, it's just going to be app insecure. Trivy prints the vulnerability scanning report for us, and from which one we can read that we have, for example, 52 total vulnerabilities. So we have 51 low and 1 medium, which is pretty good because we have no critical or high ones. Moving on, we can also see that we have an application we can see that the application dependencies are clean only. Pips show us some warning, secret scanning didn't find any exposed credentials. Trivy also offers us a possibility to filter right away with the specific level of the vulnerabilities that we want to see. So for example, when we put severity high or critical, we can filter only the specific ones. Or for example, Trivy offers us to export the results of test report in form of JSON when we put --output JSON. And we can see that here, for example, we have in the Nginx image, we have, for example, 11 vulnerabilities in total, high 9 ones and 2 criticals. Using image scanning is a pretty common practice, so it's definitely recommended to include that as a part of your software development lifecycle, for example, as a part of the CI/CD step, where the CI code will automatically trigger the image scanning command with the Trivy image scan. Part 3, multi-stage build. Multi-stage builds are quite efficient way to create smaller, safer and cleaner images in our software development. But what actually does it mean that the image is built in the multi-stage? Well, basically, multi-stage is when we are using more than once the from command, and in each of the stage we can, for example, install tools or dependencies, we can build our application, and we can copy what do we need into the final clean image. So this way, when we divide our Dockerfile into the specific builds, we can keep our final image small and free of the unnecessary build tools. Let's look at the Dockerfile of our, for example, Flask application. In the single stage build, you might install Flask, compilers, packages, package managers, and other build tools into the one image, which makes your final container, well, quite bloated, and container contains a lot of unnecessary software. This approach, of course, increases the attack surface, because every extra package or tool is another potential vulnerability that can be exploited. With the multi-stage build, all the heavy lifting, installing dependencies, building your application, is done in a separate stage, often very called builder stage. Then, once you already have the builder stage, you copy only the runtime essentials, your application code, and all of the required libraries into the clean final image. As a result, you get the container that is smaller, safer, and easier to scan with the tools like Trivy, because it only contains what is really needed to run your application with no leftover secret build tools or any unnecessary packages. On top of that, we can also run it as a non-root user, which also explained in the previous part, that only improves our security even further. In short, multi-stage builds equals fewer vulnerabilities, smaller images, and safer production containers. And that's it for today. Thank you very much for watching. Remember to subscribe.